What's up guys, Pablo Puma here, software engineer. Have you ever wondered how TikTok and Snapchat actually detect your face, eyes, lips, other features when you're recording stuff? Well, check it out. I wrote a program in C++ that's actually in real time detecting my face and my eyes as I'm talking to you. When it detects a face, it puts a pink circle around the face, and when it detects eyes, it puts a little purple circle around the eyes, and you can see it's doing it pretty successfully. If I bring in like a bottle, it doesn't like get confused or anything, or if I bring in some other object, it's not like getting confused at all. Now sometimes if I close my eye, you'll see that it actually doesn't, it's like, where's the eye? I can't figure it out. So something about having the eyes open and like having those white pixels and then darker pixels on the outside and finding those edges allows it to actually find the eyes. It's pretty interesting, and it'll actually detect multiple faces on the screen too. Like if somebody else were to walk in right now and their face was here, it would actually detect it as well. I tried it with someone earlier, so it's pretty cool. Let's jump into how I actually implemented this. So I used OpenCV, the open source computer vision library. It's a library that gives you access to a bunch of functions that you can use within your code in C++, Java, or Python to run computer vision algorithms. It's really, really cool if you haven't had a chance to use it. And Cascade Classifier is the approach that I use to detect face and the eyes. It's a machine learning based approach where a cascade function is applied on a bunch of images trained from a lot of positive and negative images, right? So essentially, you give it a bunch of data and you say, here's images of what faces do look like, here's a bunch of images of what they don't look like, and then when you give it a new image that it's never seen, it can tell you, well, this looks like it's a face or it doesn't. And the way it does this is by detecting certain features, like I was saying earlier with my image. It detects edge features, line features, and 4 rectangle features to actually figure out where different objects are. You can see like a face, you can kind of recognize it because there's like a little circle shape near other pixels in the background, and like currently in my background it's dark behind me, and so it's really easy to differentiate this dark background from this round shape around me. At least visually for you and me it's really easy, but from a math perspective you have to actually figure out by using pixels and comparing colors and figuring out if there are certain features next to each other. So now let's look at the code and how I actually went about implementing this. I implemented the OpenCV classes that I use, all the functions. The main thing was like the object detection algorithms like Cascade Classifiers. It allows you to give it that training data, which also comes with OpenCV, the training data. You pass it in to these classes, and you can essentially, you'll notice that these use the eye and the face cascade use the same class, but they use different training data. And then there's also a video capture class that I import that is used to actually grab the frames from the webcam as I'm talking to you guys. Then if I go down to the bottom to my main method, I'm actually running the face detector program here. I create the face detector class and then I run it. My run program, basically what it does is it creates a matrix from the captured frames in my webcam. It's a 2D matrix with XY values, and each image from the video capture is transformed into a matrix, and then we can apply different functions on the matrix. Matrices are really common when dealing with OpenCV. Here's the detect faces function. What it actually does is first does some normalization on the frame. It gets each frame from the video, it converts it to grayscale, which is really common when you're dealing with images actually, and then it normalizes with like a histogram approach here. Then it uses the face cascade class that I was talking about earlier to actually detect faces in the frame. So you get that face cascade class that I was talking about earlier that's been fed the training data, and it's saying, hey, here's all the data on faces. And now it's saying, now detect a face on this current frame that I'm looking at. If it does detect any faces, it puts them into this list of faces. In other words, this vector that you see here is the list of faces that were detected in the current frame. Then we iterate through each face and we display the face. In other words, we draw a circle around the face so you can see it there on the screen. Then using the face area, like within the face there must be eyes, right? So we only want to look within the space of that face and not outside of the face. So we get exactly the position of the face, and then we create a vector or a list that has all of the eyes that I'm detecting within the face, and then we run the eye classifier using the face range only, and then if there is an eye within the face, it'll put it into this list, which then we run it to a function that displays the eyes. In other words, it draws a little circle around the eye so you can see it on the screen. And just for completeness, you can see here are those functions that I was talking about. The display faces function, it just loops through the face, all the pixels of the face, and it draws a circle around, an ellipse, an oval around that face. And then on display eyes, it's the same thing, but we draw a circle. Just go through the eyes and draw it. So that's basically how I did it. You can see this is pretty straightforward in that you don't have to really do any computer vision or tough mathematical stuff to actually get it to run. And just so you can see that I am actually running it, in real time as I'm talking to you guys, I'm actually going to stop the program and rerun it, and y'all can see it, end to end, as we like to say. So now it's popped up. I'm going to, it actually pops up a new image or a new window for me that I can run the program on so you guys can see it. And there you go. It's detecting my face and my eyes. I'm going to share this code on GitHub, and I'm going to share more information about this OpenCV website if you guys are interested. Thanks for listening. Again, my name is Pablo Puma. I'm a software engineer. I talk all about really cool distributed systems, algorithms, and just technology, all kinds of fun stuff. If you're interested in more content like this, definitely follow me. I'm here for you guys. Take care.